Alright guys, so I didn't want to do this in the last video because this practice problem is a lot more involved and it's going to add a decent amount of time to that video. So instead we're going to do it separately. We have two vectors, but they are not occurring at a right angle to each other. So in the past, all we've had to do was p-thag both sides, inverse tangent for the angle, switch for the equilibrant. But here we have to do some steps first. So this vector, the 45 newtons, is completely vertical. We're going to leave that one alone. The second vector is not vertical, and it's not horizontal. So we do have to separate it out into those components. So we're going to calculate the red line, and then we're going to calculate the green line. Then we are going to combine like directions before we can p-thag. So we've kind of done this in the past, but haven't gotten too in-depth with it. So we're going to call the 45 Newton force, force 1. And we're going to call this 58 Newton force, force 2. And we have F1 in the x direction and F1 in the y direction. This 45 Newton arrow, none of it is traveling in the x direction, so I'm going to put 0 newtons there. All of it is traveling in the y direction, so I'm going to put 45 newtons there. Now the second diagram that we're calling F2, we want the x direction and we want the y direction, because just like in the past, horizontal and vertical components do not affect each other, but we do have to combine like terms. So we have to combine all the horizontals and we have to combine all the verticals. So we know that this gray arrow is 58 newtons. I want to solve for the adjacent leg with this angle and the opposite leg with that angle. So for the adjacent leg, the horizontal component of force is equal to the regular component of force times cosine theta. So F2x equals 58 cosine 35, and the x component of that force equals 47.5 newtons. Now the y component is the same thing, 58, but now sine 35 because I want the opposite leg, and the y component is 33.2 newtons. Now we have to combine like terms. So we have to combine the x's and the y's in order to make two arrows only. One going up or down and one going left or right. Fx of our new diagram is only using the second force. So 47.5 newtons, and I'm just going to draw a little arrow reminding me that that force is going towards the right because this arrow is going towards the right. F in the y direction for our new triangle, we have to combine the 45 newtons that is going up and the 33 newtons that is going down. Since these numbers are in opposite directions, to combine them we do have to subtract. So 45 minus 33 is 11.8 newtons upwards. So I'm going to draw that little up arrow just to remind me. Over here I'm going to redraw this. To the right, 47.5, and up 11.8. Now that we've done all of this, we can go ahead and draw our resultant, solve for the resultant, and then flip-flop it for the equilibrant. So to solve for the resultant, a squared plus b squared equals c squared. 47.5 squared plus 11.8 squared equals c squared. 2,256.25 plus 139.24. C squared equals 2,395.49. Square root both sides, and C equals 48.9 newtons. So our hypotenuse is 48.9 newtons. Then inverse tan of opposite over adjacent. Inverse tan of 0.248, and theta equals 13.9 degrees blank of blank. So our first arrow was east, so that goes on the second line. And we traveled north of the eastward direction. So I'm going to take all this information, I'm going to write it at the very, very top just because I ran out of room. So our equilibrant is 48.9 newtons at 13.9 degrees. And instead of north, we're going to write south. Instead of east, we're going to write west. That is our final answer. To equal out these two forces, or these two vectors, we need to apply a 48.9 Newton force at 13.9 degrees south of west. Alright, so I will see you tomorrow so we can practice with a little bit more difficult problems. Bye, guys.